Hey everyone! Have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Everyone, so the last video we talked about for loops, and we were able to use for loops to go over all the numbers in a list of values, right? So we were talking about trying to find the square root of all the numbers between 1 and 100, and we were doing this manually here, but it'd be nice if we could do this, tell the computer to do this for us. So we started with just using a list, which was this collection that we were talking about, of a bunch of numbers, and then for each of the numbers in that list, we performed the operation and printed it out. And that's the power of using that for loop. It basically will go through each of the values and perform that operation. So for here, number would be equal to 1, perform the operation, then 2, perform the operation, then 3, and it will do this all the way up until whatever we specify. In this case, this is the numbers between 1 and 10. So that's what these numbers were. But then we talked about how this could get a little arduous and this list could get very long and you have to write all of them. And we introduced this range function, which really just makes some of this a little bit easier. We took all the numbers between 1 and 11 and we printed them out. And here we took the numbers between 0 and 11 if you don't use a number first, and it will print them out. And then we use this to be able to print all the numbers between 1 and 100, the square root of of each number between 1 and 100, which was ran very quickly, but would have been a very time-consuming process here. So we're going to apply this same logic to what we've been doing with the quadratic formula. Now to go back up and to iterate how this is going to be useful for us. So we were trying out a whole bunch of different values here, and we're just hoping for the best. But rather than each time we'd have to specify a particular number. So now we're going to be able to use this test numbers and then perform this operation without having to manually check it for each one, right? So that's part of how this is useful. So if I take this test numbers and I take this equation, I'm going to use this equation with numbers from this test numbers. Now, how do I do that? So I could say 4 hours of math in test numbers. And now I need to indent here, right? This is something I didn't mention before about the for loops, but within the block of the for loop, you need to have an indent. So if I try to run this, it's going to say indentation error, expected an indented block. That's because whatever I'm referring to in this for loop needs to have an indent. It needs to be indented. So if I indent, this will work. And you'll notice here that nothing happens. The reason is because I didn't print this value out. So you'll notice in these for loops, I'm printing the number. If I didn't do that for any of these, it actually wouldn't print the number out to the output. So we need to make sure we're printing this. So if I write print around this, now we've looped through these test numbers that we've just tried out. We plug it into our fun formula, and then we're able to calculate it for each of them. And you'll see that very last value was 0, right? So that 0 was when we used 3.5. So basically, this is what we had done before. It just makes it a little bit easier. And now we have a method for doing this for a whole bunch of numbers very quickly. And that's the power of that for loop. So instead of just using these 5 numbers, we're going to use, instead of test numbers, let's use this range function and try between negative 100 and 100. Now, we have to make this on the right side. We may go to 101 in order for it to include 100 as well. And now we can calculate this for a whole bunch of numbers. So now we've calculated the same thing for every integer between negative 100 and 100. Which is really very powerful, and that's what the powerful thing is in this for loop. So that's why we want to use this for loop, is so we can quickly test this with a bunch of numbers instead of doing it manually like we did before, where it took us maybe 2 minutes to going through with 5 numbers. If we were doing it quick and we were able to do each computation in a second or 2 seconds, it still would take a lot longer than this is going to take for 200 numbers, all the numbers between negative 100 and 100. So this is where the power comes in of what we were doing. Taking a step back now, this is how we can use a for loop with the same equation we were using. But the question that I think is more interesting is how can we use this to actually find the solution to the problem? And how can we use that to do? So in order to do this, if we look at these numbers here, we tried a whole bunch of numbers between negative 100 and 100, and none of them came up as being 0. So if you look at the numbers, they have really big positive numbers here. Then you have negative number for a few numbers, and then you have a whole bunch of really big positive numbers here. So the problem here is that we know one of the solutions is 3.5. We don't know the other solution yet either. So we're still looking for that second root of this equation. We know one is 3.5 before we tried it and we got 0, but we don't know what the other one is yet. So one thing that you might think is that it looks like these values are much smaller than between negative 100 and 100, and they're also decimal values. So we found 3.5 for one of them. It's plausible that the other one is also going to be a decimal, right? And that's just a guess, but that might just be something we might think to ourselves. So one thing that we're going to want to do is, if we did have this in an adequate range, we could potentially find the value that comes up as 0. Now here, we're not really seeing that, right? We're seeing just a whole bunch of really big numbers. The first thing I'm going to want to do is change the range that I'm looking at. But the range function only takes in integers, and it will only go between integers. So first thing I want to do is translate those integers into decimals, right? To give you an example of what I mean, I'm going to say for I in range 0 to 101, print I. So this is just going to print all the numbers between 0 and 100, right? But let's say instead of looking between 0 and 100 in a step of 1, right? So each one's going up by 1. I actually want to go between 0 and 10 in steps of 0.1, right? So that might be where we find the answer here, right? Because I already tried going up by integers and I didn't find any of the zeros. But it looks like it was between these guys. And we know those guys are 2, 3, and 4, right? In any case, what we're going to want to do is we want to change this from being between 0 and 100 to being between 0 and 10 in intervals of 0.1. So the way that we do this is actually really pretty simple. If we divide each number by 10, it's actually going to divide the final number by 10, and each interval is going to be in intervals of 0.1. Again, I think the easiest way to see this, though, is to just try it, and you'll see the results. So you can see here, we're going to go 0, 0.1, 0.2, 0.3, 0.4, 0.5, and so on and so forth. So now, instead of going between 0 and 100, we're going between 0 and 10. And instead of going in 1 as the interval of 1 each time, so 0, 1, 2, 3, 4, 5, 6, 7, we're going in an interval of a tenth. So 0.1, 0.2, 0.3, 0.5. Okay. So why do we want to do this? The reason we want to do this is because we have a feeling that the solution to this is not between negative 100 and 100 in intervals of 1, but it's between 0 and 10 in intervals of 0.1, right? So now let's do something here. Let's say a number, or let's call it hours of math to be consistent. Hours of math equals I over 10. So we have an integer here. First thing we do is divide it by 10 to get what the hours of math we want to test is. And then we're going to plug this into our formula. So we're going to take this same equation up here, and we're going to print hours of math squared minus 4 times hours of math plus 7 over 4. So here, what we're doing is, the first thing for each number between 0 and 100, we're going to first calculate 1 over that number divided by 10, right? And then we're going to print out the result. So if I look at this result, I look here, now we're getting closer because these numbers are closer to 0. And we see I found a solution here, right? So first off, what is this solution? I'm going between 0 and 101 in intervals of 1 and then dividing each by 10. So what that would look like is 0 is the first one. And then the 1 would be 1 over 10, 0.1. Then 2 would be 0.2, 0.3, 0.4, 0.5. So the number, hours of math at 0.5, was the other one that made this into 0. And if we continued on, you'd actually see here is at the 35th number, right? 3.5, because 35 divided by 10 was 3.5, and that was the other root where it's 0. But this is pretty hard to read, right? And this isn't really easily understandable. So what we're going to do is we're going to print out the hours of math. And I'm also going to add this little separator here just so it's easier for us to read and separate the numbers. Okay, so we have hours of math and then the solution to the equation. So I'm actually also going to print out hours of math, and then I'm going to print out fun. Okay, so basically now it's going to print out, what it's doing here is it's just printing out extra information. So it prints out what the number is that we're testing out, and then it prints out the result of the equation, and that we're saying is fun, right? For instance, 0 plugged into this equation gives us 1.75. So 0 squared minus 4 times 0 plus 7 over 4 is 1.75. And then it goes through each of them. So 0.1 plugged into this equation is 1.35999999999, right? 0.2 plugged into this equation is 0.99. So it's basically telling us, okay, this using this number as the input, this is the number that comes out of this equation. So what we are looking for, again, is the two numbers that make this 0. Those are the roots of our equation. And we found one, 0.5, and the function is equal to 0. And then the second one is down here at 3.5. We found this before, which is equal to 0. So now, using a for loop, we can check this for all the numbers between 0 and 10. See, we're going all the way up to 10. And we check what the result of that equation is. So you can see that this makes it a lot easier for us. So rather than just us trying out a whole bunch of numbers at random, we can use Python to zoom in a little bit and find out which numbers we want to use. This was the point of using for loops, and there's a lot of applications of using for loops. This is a very useful one. Now, if you're a little bit lost, it's completely understandable. Whenever I'm in a situation like this, I think the easiest thing to do is just try it yourself. Open up a Jupyter notebook and try out using some similar formulas and seeing what happens. For instance, if you wanted to print out hours of math times 2, it might help you understand what's really going on here, right? Or if you just want to try this with a smaller subset of numbers or a larger subset of numbers, that can make sense too. So now we've been able to use this for loop, and we were able to manually find where that number is. So this is the first step, and we were able to find the two roots. It's 0.5 and 3.5, which is awesome. So instead of us trying numbers all day, which could have taken a very long time, we are now having Python do this for us and just trying a whole bunch of numbers, and it's very quick. Okay, that's everything for now. Next video, we're going to talk about how we can make this output a little bit cleaner, a little bit easier to use, and adding one of the other most important things in programming, which is conditional control flow logic. Looking forward to that, and see you in the next video.